Okay, hello everyone. This is Ringo from 7 Education, and today I'm going to go over a graph functioning circular function kind of question. It's from the November 2011 paper 1. It's one of those long questions, so yeah, bear with me. This is going to take a bit longer than my usual videos. Alright, so let's take a look here. The question here states that the following diagram or the graph is the function f of x equals a sine b x minus c plus d. Okay, so we first need to remember the meaning of these. This here is the vertical stretch. This here is the vertical shift. This one, horizontal stretch. And this one here is my horizontal shift. Okay, so before looking at any of this, I need to give you guys some of those basic knowledge. So, hope you guys remember to know how to draw a normal sine graph. Okay, so this is what we call sine theta. Okay, in a sine theta graph, we know that one period equals 360 degrees. Okay, and we need to also know that the maximum value is 1, the minimum value is minus 1. Okay, so I'm going to have a variation of this graph and see what you can tell me. If this becomes, whoops, that's a bit awkward. If this top part is 2, this bottom part is minus 2, this graph becomes, whoops, this graph becomes what? Becomes 2 sine theta. Simply, we know that the total distance here is 4, and we divide that by 2, we get 2. So we know that it's been stretched by a scalar factor of 2. So therefore we add 2 sine theta. Okay, let's have a look at another variation. Okay, if I move this graph on top, I'm just going to change the color so you can see clearly. If I'm going to move this graph up like this, this becomes 2, this here becomes 0. The total distance is still 2 divided by 2, which is equal to 1, which is still a sine theta graph, but it's been shifted up vertically by 1. So we have to go sine theta plus 1. Alright, that's the easy part. Okay, so another basic concept that I need to bring your attention to. Normal sine graph, we have 0, 90, 180, 270, 360. That makes one period, okay? But then, what if I have a graph like this? Change the color again. Let's use this one. So instead, this becomes 45, 135, 180. Okay, you can see that this graph has been squished together. It's been like, whoops, squished together like that by half. So normally it takes, in a normal sine graph, it takes 360 degrees to complete one period. But in here it only takes us, whoops, but in the graph here it only takes us 180 degrees. So guess what we do? We simply just go 360 divided by 180 equals 2. And so therefore, this is not a sine theta graph, it's a sine 2 theta graph. It's just that simple. And then, last but not least, to explain our horizontal shift. Okay? I'm going to use the same diagram. So, in this graph, if I move it here and it starts something like this, the graph has been shifted by 90 degree, right? So basically in our graph here, it would be a sine bracket theta minus 90 graph. Okay, reason being, if we shift to the right, it's minus. If we shift to the left, it's positive. It's just, yeah, it's kind of weird to think that way, but you need to start thinking that way for these graphs. Alright, so we have kind of the basic done. We can look back at this graph. Yeah. Alright, so let's find A first. Okay, we know the maximum is 12, the minimum is -4, the total distance in between them is 16, and guess what we have to do? Divide by 2, right? So that equals 8. So we know A is simply 8. Okay, normally in a 8 sine theta graph, the maximum value is 8. Oh, I'll draw it so you guys can see it. Normally is 8 and -8. But now they have moved it up so that it becomes -4 and 12. So if we go -8, -7, -6, -5, -4, we would have moved the graph vertically up by 4. So simply D here, the vertical shift, would just be 4. Okay? And now for the more difficult part, which is the horizontal shift. How do we tell this from here? Alright, so I'm just going to get rid of some of these so we can see it clearly. Alright, so at this point here, we know it's 4. This point here is 8. And I want to know what is it at this point here. Well, because this is symmetrical, we know that the midpoint between 4 to 8 is 6, and therefore this point must be 2. This is logic. Alright, so because of this, we can tell that C is simply 2. Alright, that was the easy part. Now let's do part B. Show that B is equal to pi over 4. I talked to you about that B is what we call the horizontal stretch. We want to find out how much the graph have stretched or shrinked. Usually in a sine graph, one period, I told you guys, was in a sine theta graph, one period was equal to 360 degrees. Now in our graph, what is one period? Okay, so how do we determine it? Okay, so from point 12 here to 4, oops, sorry, my bad, from 4 to 8, this is actually half a period. So if we want to complete the full period, it would be 4, 8 to 12 here, which is not drawn on the graph. So the total of this period becomes what? It becomes 8, right? 12 minus 4 is 8. So in this graph here, one period is actually 8. So simply 360 divided by 8. And we know 360 is what? 360 is actually 2 pi over 8. Simplify that, we get pi over 4, which is that answer there. Alright, that was the easy part. And here it says find the differentiation of this equation. F dash x. Okay, we're gonna need some space. Okay, so let's write out the equation again first. So let's write f of x is equal to 8 sine bracket pi over 4 bracket x minus 2 plus 4. Okay, so let's move this here, so we get a bit more space to do this question. Okay, so now we're trying to find the differentiation of this equation. Okay, so f dash x, we need to use we need to use first the trigonometrical differentiation function. So we know that sine becomes cosine, and the inner bit, I'm just going to expand it because it actually doesn't change, minus, oops, my bad, minus pi over 2. Okay, and because we know from the chain rule we have to differentiate it one more time, we have to differentiate this inner part one more time, so it becomes pi over 4. Okay, so that was relatively simple. Okay, so next, what are we doing? Next we're doing this. Okay, so let's simplify it. Okay, 8 pi over 4 cos bracket pi over 4 x minus pi over 2, we get 2 pi cos pi over 4 x minus pi over 2. Alright, that's it. Okay, so next part, it says find the gradient. Find the gradient. Whoops. Okay. Find the gradient at point R when at the point R the gradient is minus pi over 2. Find the coordinate of R. So gradient is actually, oops, my bad. This, so minus 2 pi equals 2 pi cos bracket pi over 4 x minus pi over 2. Okay, simply let's divide this over. Minus 1 equal cos pi over 4 x minus pi over 2. And then next we have to, well, inverse cosine it. So we know that when we inverse cosine it, it's minus 1. So let's draw a cosine graph, okay? So cosine graphs look something like this. This is 0, 90, 180, 270, 360. And minus 1 is actually 180. 180 is just pi. So when we inverse cosine minus 1, it's just pi equals pi over 4x minus pi over 2. So next what do we have is this. Okay, pi plus pi over 2 is what? 3 pi over 2 equals pi over 4x. And then we divide that over, so 3 pi over 2. So when we divide, we flip the reciprocal of it, equals that. Okay? Pi and pi cancels out. So we have 3 times 4, which is 12, over 2 equals x, which is equal to 6. So we know that the x coordinate of R is simply 6. Alright, that was a super long video, and I'm pretty sure you guys have to watch it once or twice before you can fully understand this question. Alright, thank you for watching, and I'm Ringo from 7 Education.